planet Mars is the fourth planet from the Sun in our solar system, the next one beyond Earth's orbit. Because of that proximity, it has been the topic of many a science fiction film, all of which keeps the idea of possible life on this red planet in the back of our minds. But what do most people really know about Mars? And how can such skills as reading, writing, and math be integrated into a lesson to help adult learners get the most out of studying this mysterious planet? Well, Susan Coles and her adult education students at Lynn Benton Community College in Albany, Oregon, did it by participating in an electronic field trip, which then led them to many other activities.
This is a class of between 15 and 20 adult learners who are part of the Job Opportunities and Basic Skills program. It's a multi-level class. It is a modified open entry, open exit in that students are coming in about every 4 weeks. They, as with other adult education programs, their attendance can sometimes be erratic for a variety of reasons. So it isn't a consistent year-long class that a teacher might expect in the K-12 program. The students in this program are here to update their skills in reading, critical reading, writing, and math. They also may be working towards the GED, or the Certificate of General Educational Development. So they're required for that test to be able to pass a lot of subtests in science, social studies, and writing, math. And there are a lot of skills that they really need to work on. I think the way to learn those skills is always to do that in the context of a real-life situation or in the context of some interesting situation. And so I really like to use these electronic field trips, such as this Live from Mars, as a basis on which to find out some interesting information, to have some fun, and also to be learning those math, writing, and reading skills.
If I want to look up this for the Mars today, I'll just look one up. There's one. The upper left panel, diagrams. And if I want to look up any more information on Earth and Mars through 1996, I'll click here. It will help me a lot in looking up Mars stuff instead of looking through the dictionaries and stuff. I'll just click in Mars, and it helps me more faster and stuff. Since my first time working on computers.
An electronic field trip, such as the one Live from Mars that we've been involved in, is a great online opportunity for students to go through the classroom walls and out into the real world. Usually an electronic field trip involves a website with a lot of online activities that students and teachers can use. It also involves usually a field trip to a remote site with live satellite transmission and some interaction that's possible between learners who are watching the site and the activities that are going on there. In the case of Mars, we haven't actually gone to Mars, of course, but a little while ago we went to the Jet Propulsion Laboratory in Pasadena, California via satellite with one of these electronic field trips. And we listened to the different scientists who were talking about their plans for the landing of the Mars Pathfinder in July. We watched a lot of rocketry examples and rover simulations. This Live from Mars program is a part of the Passport to Knowledge series that is put on by NASA and the National Science Foundation and PBS. And it is possible to get all these materials online at no charge. Students use technology in this project in a variety of ways. They have access to the websites on the internet, and so as they're trying to find out information about Mars, for example, comparing Mars to Earth, they're looking at a lot of different sites on the internet where they can get up-to-date information.
Right now I'm looking at Mars, and it's coming straight from Arizona. Okay. I didn't know Mars had a symbol until I started looking on the computer. I didn't know all the planets had different symbols. But anyway, I found out the distance between Mars is 1.5 distance between Earth and the Sun. On here they have it in metric. Okay, so of course if we want it in miles, we have to look up to find out the proper procedure to look up between meters and miles.
students can actually get today's weather on Mars if they want to. There's a lot of raw scientific data there on site. Another thing that students can do with internet-based resources is that they can send email messages to the experts who are involved in these projects, and then they can receive answers via electronic mail to those questions. Okay. It's possible also then to get the teacher's guide with all of these wonderful activities just right here from the website itself. There are activity sheets, student activity sheets that can be printed out, and they're just ready to go. But this is an example of the teacher's guide, activity 1.1b, rockets and payloads. It gives the objective, it gives all the materials you need for a science team of 3 or 4 students. You need the balloons and the balloon pump, fishing line, paper clips, paper cups, straws, and tape. The Engage, it tells you how to, it's a standard teacher's lesson plan, really is what it is. The procedure, and then all sorts of other connections that you can have, and this one suggests that you go online and find information about the Mars Pathfinder or the Mars Global Surveyor to find more information, or to read, once again from the experts, their field journals, their biographies, and then of course the students could construct questions, email questions that they ask the experts if things aren't clear to them. From this experiment, the students learned that there is an equation, there's a second law, Newton's second law of motion, force equals mass times acceleration. Now, if you were just going to have that in front of you, what a problem. It's not too clear to me, but by doing this experiment and by changing the variables, by changing the weight of the payload on the balloon rocket, then we were able to discover that relationship. This opens up a wonderful opportunity for a variety of great activities. For example, we have in this classroom been studying Newton's laws of motion, 3 laws of motion, and this is directly related to rockets and rocketry. And so we've been conducting experiments here, which are a part of the teacher's guide and suggested as a part of this package. We've been conducting experiments with balloons to test payloads and to figure out, well, how do rockets actually take something out of the Earth system and into another dimension. They were given information about a mystery site on Earth. And this was something that they worked together, worked in pairs or teams, I think. They were given a description of the biome. They were given a description of the flora and fauna of that site, of the soil, of the temperature at a particular date, the wind speed at a particular date. This was all raw data from a particular site. Then they were supplied with 5 possibilities of what that site really, where that site really might be. And then they had a very few days to work and figure out which one of those 5 sites would they actually choose as probably following along most of the parameters that were given by the Live on Mars people. This was, as I say, very challenging. They used CD-ROMs, they used internet-based sites, they used atlases and maps, and then they tried, mainly by a process of elimination, they tried to figure out what was their best site.
One of the clues on our mystery site, it had the temperature on the exact day. So I used a process of elimination. So I went over the computer and I tapped in the National Weather Service so I could find out the archives for the back weather temperatures, you know, so I could look up what the temperatures were on those days. That way I could use a process of elimination, and that way I could get closer to what I was looking for.
We got the sites from, down from Mars, and we had to go with the flora and the fauna and the latitude and longitude with each one, and we had to find the mystery sites and which one was directly our mystery site, and that had, like the descriptions on here, and they had to fit, and if they didn't fit, then it was the wrong site. And I had to go search through the internet, and otherwise I wouldn't have been able to find all the information on the things that we needed for our mystery sites, and then that way we could match it up, correlate it, make sure it was the right and what was the wrong. If we wouldn't have had the technology of the computers searching through the internet, we would have been here all day long with atlases and almanacs forever. It would have just took forever. I mean, it was like really quick. We were over there for about less than an hour. All this stuff started printing out. We could put whatever we wanted in there, and it was just coming out of there, and it's like We could just match everything up. Otherwise, we'd have been there forever.
The students in this program have a variety of levels of literacy skills, and of course literacy is broadly defined, not only to be able to read, but to be able to compute, to write, and to have scientific literacy and technological literacy. So students are able to work on all those forms and definitions of literacy by using technology in this classroom. And because they're able to relate those skills or use those skills in a context, working with a subject matter that is of interest to them and usually something that they've defined for themselves as something they want to learn about, then the motivation level is far higher and they see a reason for learning. They also say to me that if they had had this kind of instruction when they were in school before, where something was reality-based and made sense to them, they probably would have stayed in school, and they're hoping that the same thing is happening for their own kids in school now.